everyone, this is Nitya Priya, and even today in operating system we are going to see the terminology and the functions of operating systems. We are going to see the terminology and the functions of operating system. When we are seeing about the terminology of operating systems, we will also see the computers on early days and also the hardware and the other features on early days. So these are the things we are going to discuss in terminology, and we will also see the different states of a process. Then we will move on to the functions of operating systems. Yes, these are the contents, terminology and the functions of operating systems. Yes, this is the relationship of operating system with a computer system. We know pretty well that, I will zoom it, you know pretty well that an operating system just gels the computer user with the computer hardware, and the computer hardware here we mean as a bare machine. See the bottom of the picture, you see bare machine. Bare machine is the hardware. So when the computer user wants to be connected with the computer hardware, he'll just use his own application programs and also the utility programs. Then with the help of the operating system, he connects with the hardware. So in the picture you see the application programs and the utility programs. They are compilers, assemblers, editors, linkers, loaders, etc. Then below that the operating system is. The operating system it does several services to the users of a computer, like memory management, processor management, device management, and file management or information management, like things. So through these services it helps the computer user to get connected with the hardware. So this is about the OS, the relationship of operating system with the computer system, right? And this is the computer system in early days. So there is no OS here. You see the memory is connected with the processor. Processor in turn will be connected with the devices like card reader, printer, magnetic tapes, etc. So there is no OS here. Only the memory and the processor are there, right? So now we discuss about the main memory. We see what main memory is. Main memory is, we know, the hard disk of the computer, or the core memory of the computer is called as main memory. The instructions and the data of a computer are stored in the core memory, which is also called the main memory of the computer. So that is the main memory. Now it is CPU. CPU is the processor, and that is the main part of the computer. We can say it is the heart of the computer. So CPU is a processor which performs arithmetic operations upon data in memory. So by getting data in memory, the CPU performs the arithmetic operations. It also executes the instructions that control the other processors. A system can have more than one CPUs, right? So then we see I/O processors. I/O processors are the processors that manipulate the I/O devices that in turn handle the data movement between the memory and the I/O devices, right? And now we see software. Software is a collection of programs or data used to perform certain tasks. So this is a software. Then we see program. A program is a sequence of instructions. So we can also see program here. So program is a sequence of instructions, and the collection of these programs is known as a software, right? So then we see compiler. A compiler is a program that translates the source program in high level language into the machine language or the object code. So the object code is the compiled code, we know. The compiler is the one, it is the system program, or it is a utility, we can say. That is a utility which transforms the high level language program into the machine code. And this is the basic computer hardware. You see, I'll zoom the picture. On the top we have memory. The memory is connected with I/O processors and the CPUs. The I/O processors are connected with control units that in turn are connected with the external devices or the storage devices like disk, drum, tape, Printer is a output device. It is an output device. So printer, card reader, etc. So the entire thing is called as the computer hardware. Memory, I/O processor, CPU, control units and the devices. Now user. We see who an user is. An user is anybody who desires to work with the computer system. So user is the one who works with the computer system. Then we see job. A job is a collection of activities required to do a work. Right? So a job is a collection of activities required to do a work on a computer by default. There are 3 steps to complete a job. They are compile, load and execute. Now we see, so early stage I said we will also see the states of a process. So we see that states of a process. So a process is an activity that executes a program, right? So that is a process. A process will be carried out by the processor, that is CPU, right? So we see the life cycle of a process. There are 3 main states in the life cycle of a process, namely run, wait and ready. As you see on the screen, the run state of the process says the process is assigned a processor and is being executed. So when a process is in run state, it has been assigned a processor and is currently being executed. So that is run state. The second one is wait state. In wait state, the processor is waiting for some event. Okay, some signal from the user or some signal from the devices. The process will be waiting. So that is the wait state of the process. The third state is ready. The process is ready to run, but there are more processes than processors. So it must wait for its turn for the processor, right? So the number of processes is more than the number of processors in the system. So obviously the process that is ready is waiting for some processor to get. Okay, so after getting the processor, the process will be coming to the run state. So that is the third state. So these are the 3 main states of a process, right? So these 3 states we see in this diagram. See, I'll zoom it. We see on the top the run state and on the bottom we see ready and wait states. So what is run state? Process assigned to the processor. So that process is a run state. The next one is wait. Process must wait for some I/O completion. So that process is from ready state, it turns out to the wait state. So what about the ready state? I/O has been completed and is ready to be running. Okay, so that is called as the ready state. So these are the 3 states of a process. Then, so see, here we see the model of process states. See, no? We saw 3 states of a process, 3 main states of a process, and they are ready, run and wait. So those things we saw, right? Here in this diagram we see 3 more states. See, submit state, hold and complete state. So what are they? These are the 3 added states of a process: submit, hold and complete. So we see that the user is submitting a job. So it is on the hold state. It comes to the ready state. It will run or it will run. So after running, it may come to ready state or to wait state. So from waiting state to running state, it has to come to ready state. Then only it can run. So after the execution is over, it comes to the complete state. So that is the complete cycle of a process. We see the 3 added states. Submit. A user submits a job to a system. So that is a submit state. When a user is submitting a job, so that state of a process is called submit state. The system must respond to the user's request, of course. So the next one is hold state. What is a hold state? A user's job has been converted into internal machine readable form, right? So after submit, it comes to the hold state. So in that state, the job is converted into the machine readable form, but no resources has has yet been allocated to the process, right? So the last one is complete state. So obviously when the process is over, it comes to the complete state, right? So the process is a computation needed to do a job, right? So the more than one computations may be carried out at the same time. So that computation is called as a process. Then address space. The collection of programs and data that is accessed in a process forms an address space. Then we see multi-programming. So nowadays we work with multi-processing environment, multitasking, multi-programming, right? So this is a main terminology in operating systems. So what is multi-programming? Multi-programming is the environment where multiple processes are in the state of execution at the same time. So more than one processes being executed concurrently is called as multiple programming environment. Now interrupt. What is an interrupt? So usually when a process is being carried out, something will stop the process from being processed. So that state is called as interrupt, right? So what is that interrupt? An interrupt is a mechanism by which the processor is forced to take note of an event. Okay. So now we see the functions of operating systems. There are 4 functions of an operating system. Operating system performs 4 services or 4 functions to the computer users to use the computer hardware. They are memory management, processor management, device management and file management. We see everything in detail one by one. First thing is memory management. So in memory management, the operating system keeps track of the primary memory, which part is in use, by whom, how long it is registered, and which is not in use. All these things are monitored by the operating system. So in multi-programming environment, the OS decides which process will get memory, when and also how much. So this is the second task of memory management, which is done by operating system. And as a third task, it allocates the memory when a process requests it. As the fourth task, it deallocates the memory. So when it is used, when the task using by the memory, the memory is used, when the memory is used, the memory will be again got back by the OS. So this is called as deallocation of memory. So the 4 things are called as memory management done by the operating system. The next one is processor management. So the program which is responsible for keeping track of the processors is known as the traffic controller. So by the use of traffic controller, the OS performs this processor management, right? So it allocates the processor, which is CPU, to the process which is requesting, and it also deallocates the processor when it is no longer required. So this is called as processor management. The next one is device management. Device management is just keeping track of the devices which are connected to the computer. This is called device management. When it is required, it will be allocated. When it is ready, then the device is available, and when it is required, the OS will allocate the device, or it will just put the process in wait state, right? So after the device is used up, it will be again got back. Deallocation will be done. So all these tasks are known as device management. That's it. Then the next thing is file management. File management is the collective facilities of the files is known as a file system. So with the use of the file system, the OS just keeps track of the information, their location, the users who are using it or the users who are accessing it, and the status of the files, etc. So all these things are monitored by the operating system with the help of the file system. So the operating system decides who gets the files, and so on, right? So that is the second task. And the third one is it allocates the files when they are requested by the processors or the users. And finally, when it is used, when there is no longer requirement of the particular file, it will be got back by the operating system. So everything is called as file management. So here we saw the terminology of operating system and also the 4 important functions of operating system. And I have given some web references. I have collected the materials from web as well as from your textbook. Hope these links will be useful to you. This is for a better understanding. And finally, thanks for watching.